Question number 7. Guys, this is a really cool question. I won't say it's easy. This is a bit challenging. So we are going to slow down our speed, but I rest assured all of you will be getting. But this is really a good level question. So whenever required, I'll be explaining the supporting concept and everything so you understand the complete question. So let's start the question, guys. Jack, Kate, and Elisa registers the following average times when running around the school oval. So Jack takes 1 minute 20 seconds, Kate 1 minute 12 seconds, and Elisa 1 minute 3 seconds. If they all stand at the same time from the same place, how long will it be before they pass the starting point together? I think we will understand the things a little bit, yeah? So let's say whatever the information is given, whatever needs to be, we need to work it out. Let's put that aside. Let's make the things very simple first. Let us say in case if Jack is, so I'm changing that a time for a moment so that you can have a bit more idea about what we can do and things like that, yeah? So let us say if Jack is taking 2 minutes. All right, I'm just giving you a simple scenario, 2 minutes for one round. If Kate is taking 3 minutes, and then Elisa is taking, let's say, 5 minutes. Then, let's say they all are starting together. So after how many minutes, if they keep on running, after how many minutes they all will be together. So for that, guys, I'm going to take the lowest common multiple of this. So lowest common multiple of 2, 3, and 5. I'm going to find out a number which comes in the table of 2 and 3 and 5 all. So lowest common multiple of 5, 3, and 2. So how can I work it out here? Is like 5 is the biggest number. 5 doesn't come here. So I can do like 5 2s are 10. 10 doesn't come. 5 3s are 15. 15 doesn't come in 2 table. But 30, if I take 30, guys, so 30 is the lowest common multiple. So 30 minutes, that comes in here as well. So the first person can finish 2 times 15, 15 laps. Second person can finish 3 times 10, so 10 laps. And this is like 5 times 6, 6 laps, and they all will be together at the starting point after 30 minutes. So whatever is the different time, you're going to find out the lowest common multiple, and that's the time they all will be together. So what we did so far, we didn't start solving the question, but we try to understand the fundamentals required to understand the question. Now I'll take my times off, guys, because I'll be working with the real times. So what are the real times? 1 minute 20 seconds, 1 minute 12 seconds, 1 minute 3 seconds. Now you can't get the LCM when it's minutes and seconds. So very first thing is, I'm changing all the time into only seconds. So I'll be just changing all the time into seconds. So I'm just writing out what is the time everyone is taking in seconds. So 1 minute is 60. So for the Jack, 60 plus 20, which is going to be 80. So Jack is taking 80 seconds altogether. Kate is taking 1 minute 12 seconds. So 60 plus 12, 60 plus 12 is 72. So Kate is taking 72 seconds. Elisa is taking 1 minute 3 seconds. So 60 plus 3, which is going to be 63 seconds. So they are the times 80, 72, and 63. Now my job is, if I can find out the lowest common multiple of these 3 numbers, that is the time they all are going to meet up again at the starting point. Now finding out lowest common multiple of 80, 72, and 63 is a nightmare, isn't it? So I'm going to give you some cool way how can you find out the lowest common multiple of such a big number. What am I going to do, guys, is I'm writing just 80 here. I'm writing down 72 here. And I'm writing down 63 here. I am going to change all these numbers into their lowest, like prime numbers, guys. So I'm going to split them, like let us say 80 is nothing else but let us say 8 times 10. And then I can further change that into 4 times 2. And this is going to be 2 times 5. So I'm just making a prime number 3. So now this cannot go any further. So I'm going to just make a circle. That's done. That is also done. That is also done. 4 I can still further bifurcate into 2 times 2. So that is done as well. So now what are the all factors of 80 in terms of like prime factors? So I can say 1, 2, 3, 4. There are 4 2's. So I can write down that is 2 power 4. Why power 4? Because 2, 2, 2, 2. I have got 2 4 times. Multiply by 5. So I resolve my 80 into prime factor things, guys. That's going to work like anything, huh? Just have a see. So now the second one I'm going to do, let's say 72. I can divide any way I want. So I'll be dividing, let's say 9 times 8, and 9 I can further divide into 3 times 3. 3 and 3 both are the prime factors, so I'll be circling because that's what I'll be taking at the end. 8 I can divide into 4 times 2. So that 2 is a prime number, but that 4 I can again divide into 2 and 2. So now that is completely divided. Okay, what are my, how many 2's? 1, 2, 3. There are 3 2's. So you can write down 2 power 3. Multiply by how many 3's? 2 3's. So you can write down 3 power 2. So that's what I change 72 into prime factors as well. Now 63. 63 is nothing else but 9 times 7. And 7 is already a prime number, so I'll be circling that. And 9 is going to be 3 times 3. And I'll be circling that. So that will be nothing else but 3 square, because 2 3's multiply by 7. Guys, have a look. What we have done is 80, 72 and 63. I just represented them in a prime factor way. So what are my final answers right here? Can you see? 2 power 4 times 5. Here it's like a 2 power 3 and 3 square. And here is 3 square times 7. Now, when I want to get the lowest common multiple of this, I'll be just looking at the prime factor, guys. Let's say I'm just talking about only 2. So what is the 2's highest power? That's what I'm going to take it. So here 2 power 4, 2 power 3. Here there is no 2. So whatever is the highest power, I go to take in LCM. So whenever I'm considering LCM for that thing's highest power. So 2 power 4 is the biggest for the 2. So I'll be just considering 2 power 4. I don't need to worry about 2 power 3. That's already taken care of because 2 power 4 is the highest power. After that, I'll be just focusing on 3. So here is like there is no 3 here. 3 power 2, 3 power 2. So 3 power 2 highest is 3 power 2. That's what I can also take it. Now 5. 5 is there is only one 5. So I got to consider that as well. And 7. There's one 7 here that I got to take it as well. So I should not miss any of my prime factors. At the same time, when there is like a 2 here, then like I got to just consider whatever is the biggest power. So that is the number, guys, which is the LCM of 80 seconds, 72 seconds, and 63 seconds. Now we can try to get that like easily. That should not be very hard, yeah? So to make our life easy, guys, let's say 2 power 4 is going to be 2 to the 4 to the 8 to the 16. So that number is going to be 16. 3 square is going to be 9, and this is 5, and this is 7. Now what we can do is 16 times 5 is going to be 80. I'll write down 80. 9 times 7 is going to be 63. So 80 times 63. But that answer is in seconds because all the numbers I have changed into seconds so that I can take the LCM. So this is in seconds. I want the time in minutes because the time given to me is in minutes. So if I want to change that seconds into minutes, this final answer I'll be dividing by 60 so that it's already changed that into minutes. While doing that, I can do like 0 and 0 is cancelled. 8 and 6. I can say 2 common, so 2 4s are, 2 3s are. And the last thing is 3 and 63. So 3 2s are 6 and 3 1s are 3, so 21. 21 times 4. So 21 times 4 is 84 minutes. So 84 minutes is my LCM in minutes, and that's the time all these people, Jack, Kate, and Elisa, are going to meet again. So my answer C, 84 minutes is the answer. I hope you enjoy the question. Not really easy. I recommend, strongly recommend, watch these guys like a second time, third time, pause in the middle, try something to understand, but watch it few times, and definitely I'm pretty sure you'll be getting this wonderful, harder thinking question, guys.